Okay, I'm going to go through as many of these as I can. This is Poisson, and we have the mean of 3, and it wants us to use a table. So if we know the mean is 3, and we want to know the probability that x is 5. So you have to scroll down till you see 3 for x right here, and then go all the way down until you find 5, and you can see that your number here is 0.1008. And then for x is greater than 6, when you pull up your table. Now, the way that you want to do the probability of something greater than with Poisson is you have to use the complement rule. So if we want the probability of x is greater than 6, we make sure it says 6, yeah. So what you have to do is use the complement to that. You have to say 1 minus the probabilities that we don't want included, because greater than 6 is 6 to infinity. So we need to subtract, we need to use the complement rule. So the probability of 0 and the probability of 1 and the probability of 2 and the probability of 3, the probability of 4, the probability of 5, and we want the probability of greater than 6, so that would mean 7 to infinity. So we also have to subtract out the probability of 6. So what you do is you go to your table and you go to 3 and you add up 0 all the way to 6. So 0.0498, 0.1494, 0.2240, 0.2240, 0.1680, 0.1008, and 0.0504. You're going to add those up and say 1 minus those, and that would give you your probability of x being greater than 6. Now, if it's equal to or less than or equal to, you just find the values in your table. If you wanted to know the probability that x is less than or equal to 3, that means you want the probability of x being 3, 2, 1, and 0. So go back to your table and add up all of these numbers under 3 from 0, 1, 2, and include the probability of x being 3. And when you add those up, you would get 0.6472. So it's mainly looking at your table and figuring these out. So for the next one, the probability of exactly 5 occurrences, we know the mean is 5.5. So if we find 5.5 on here, exactly 5 occurrences would be 0.1714. And then more than 6, so here what we would have to do is go back to our table. Let me extend this down a little bit. Alright, go back to our table and go to 6, and we want more than 6, and our mean is 5.5. So go to 5.5, and more than 6 means we're going to take 1 and subtract out. Let's start with the point greater than 6, so we're going to include 6. So let's start with that one. 1 minus, and then we're going to do 0.1571, 0.1714, 0.1558, 0.1133, 0.0618, 0.0225, and 0.0041. Subtract all of those out. Let's see, I need to, okay. And I got, if I didn't make a mistake, I got 0.314. Okay, the probability of 3 or fewer, go back to your table right where we were at 5.5. 3 or fewer means we're just going to add 3 and go down and add all those up. So 0.1133 plus 0.0618 plus 0.0225 plus 0.0041. Let's see. I got 0.2017. Oh. Okay, on the next one, we want to know the probability of 5 occurrences when the mean is 2. Okay, so let's pull our table up. Okay, so on this one, it's actually wanting us to use the formula. It did not provide us a table, so that's kind of how I knew that I would plug into the formula. So we're doing the probability, I believe it was of 5. No, 2. Wait. The probability of 5 occurrences where the mean is 2. So the formula is, you're going to use E, which is 2.71828 raised to the negative mean, and the mean is 2 on the first one. And then times the mean of 2 to the x, which is 5, because we're wanting 5 occurrences, times 5 factorial. So I'm going to put that in the calculator. I'm going to do 2.71828 to the negative 2. And it's a long decimal, so I'm going to times that by 2 to the 5th. And it's a long decimal, I'm going to divide that by 5 factorial, which is 5 times 4 times 3 times 2 times 1. And I got 0.0361 if I round to the 4th decimal place. Okay, and then the next one, we want the mean is 3 this time. So we're going to do 2.71828 to the negative 3, and then 3 to the 5th over 5 factorial. So the only thing that changed was the 3. So 2.71828 to the negative 3rd power. And then I'm going to times that by 3 to the 5th and divide it by 5 times 4 times 3 times 2 times 1, which is really just 120. And then you get 0.1008. And I don't round anything until I get to the end. And then for this last one, we want the mean to be 4. So we're going to do 2.71828 to the negative 4, 4 to the 5th, over 5 factorial. Divide it by 5 factorial, and I got, let me check that one again, times 4 to the 1/5 divided by 120 is, I got 0.1563. Okay, what conclusion can be made about how these probabilities change with the mean? So you could see as the mean increased, the probability increases. Okay, for number 4, to find the mean of a Poisson, the mean is given to you here. And then the standard deviation, the variance will be the same as the mean. So the variance is 16.8 as well. So the standard deviation would be the square root of the variance or the square root of the mean. So it would be 4.099. Assume the number of births in a local hospital follows the Poisson distribution and averages 2.3 per day. Complete parts A through C. What is the probability that no births will occur today? So I'm going to view the example. Okay, I think they want you to use technology. So I'm going to use StatCrunch. And I'm going to say CalcStat, calculator, and I'm going to go to Poisson, and my mean is 2.3, and I want the probability that there will be no births, so put equals, and we want it to be 0, so the probability would be 0.1003 if you rounded to the 4th. The probability that fewer than 6 births will occur today, fewer than 6, so less than 6. So go to Stat, Calculators. We want it to be less than 6, and I think the mean is 2.3. So compute, we would get 0.9700. Let me put that in. What is the probability that more than one birth will occur today? So more than one. So more than 1 and 2.3. So 0.6691. Okay. So Sarah's a salesperson. She's averaged 1.9 extended warranties per day. Assume the number of camera warranties that Sarah sells per day follows the Poisson distribution. What is the probability that Sarah will sell 4 extended warranties? So the mean was 1.9, so I went to my Poisson calculator, and we want the probability of exactly 4. So that would be 0.0812. The next is the probability that she will not sell an extended warranty, so the probability of 0. So enter it into the Poisson calculator. The mean is 1.9, the probability is 0, so your answer is 0.1496. And then the probability that she will sell more than 2 extended warranties, so greater than 2. So greater than 2 would be 0.2963. And then what is the standard deviation for this distribution? It would be the same as the square root of the variance. The variance is 1.9, so the square root of 1.9 will be 1.3784.